Welcome back to our exam game. So this is our next part of areas related to circles. So this will be the third question. So this is very similar to the last question we have done. We have we have a square ABCD, and the side of square is of length 14 centimeters, and we need to find the area of the shaded region. So we can see two semicircles. We can see two semicircles. So this would be something like this: circle number one and circle number two. So there are two semicircles and we are given one side of the square is 14 centimeters. So we know all sides of square are equal. So this would also be 14 centimeters and this would also be 14 centimeters. So taking the midpoint, this will become the center of the circle. And if we have taken the midpoint, then this length would become 7 centimeters. So we get the radius of the circle, the semicircle, as 7 centimeters. Now we need to find the area of the shaded region. First we will find the area of both of these triangles. We can see that both of these angles are 180 degree. Sorry, we will find the area of these two semicircles. Both of the angles of these semicircles is 180 degrees. So now what we will do next is that we will try to find out the area of both of these and subtract it from the area of the square. So let's first find out area of square ABCD. This is the side square is 14 into 14. This will be 196 centimeter square. Next we get area of one semicircle. Area of semicircle. So we know area. So look. So this was a circle, and we know that this becomes a sector. This is a sector of a circle. So semicircle is a special case of sector. So let's imagine that this was a 60 degrees. Let's imagine that this was 60 degrees. So semicircle is special case when this angle becomes 180 degrees. Semicircle is special case when this angle becomes 180 degrees. But this also remains a sector, right? This also remains a sector. Just the angle is 180 degrees. So area of semicircle would be 180 degree by 360. 360 degrees. Cancel and we get 2. Multiplied by pi. Let's take pi 22 by 7. And r square. R is 7 into 7. 7 and 7 gets cancelled. Get 11. We get 77 centimeters square. So this was the area of one of the semicircle. We need to find out both. So we will multiply 77 centimeters square into 2. This is equal to 1. This would be 154 centimeters square. And this is the area of both semicircles, correct? So this is the area of both the semicircles. Now subtracting the area of square minus area of both semicircles. This would be equal to 196 centimeter square minus 154 centimeter square, which is equal to 42 centimeter square. Correct? So we get the area of this shaded region as 42 centimeter square. So what was my approach was that we had a figure. We needed to find the area of the shaded region. We can see it is a square, and we can also see that these are two semicircles. So since we do not have any chapter which has semicircles in it, no chapter has semicircles in it, so we cannot use the formula. Like we know the area of the circle. We know area of circle is pi r square. Correct? So what would be the area of semicircle? It would be pi r square upon 2. It would be the area of semicircle technically, because semicircle is half of circle. But since we do not have any chapter related to semicircles, so whenever this question would come in the exam, you would always use the area, which is theta by 360 multiplied by pi r square. Look, theta, what was theta? It was 180 degrees in both cases. By 360 multiplied by pi into square r square, which is 7 into 7. So that is why I use this formula. I could have also used this formula. Let me just solve it by using that. What is pi? 22 by 7. 7 into 7 upon 2. These get cancelled. We get 11 here. We get 77 centimeters square. The area of the semicircle. So the area of semicircle in this case is also 77 centimeters square, and in this case as well it is 77 centimeters square. Hence it does not make any change, but we should always approach it by this formula, theta by 360 into pi r square.